So, for our definition of a midpoint, what do you think a midpoint would be if you had to define it? A point that lies in the middle of a, not a line. Why can't we have a midpoint of a line? Because it goes on and on forever. So it has to be a midpoint of a segment. Good. All right, so please write down in your notes that the midpoint is the point that divides the segment into two congruent segments. Okay, so if I were to think about the middle of something, let's say that this line up here that I am drawing is, I don't know, what does that look like? 3 feet? Does anybody know whose that is? Do you want to turn that off? Don't be embarrassed if it's yours. Just come up and turn it off. No? Okay, we'll keep listening to it. If the whole thing is 3 feet, what would be the middle of 3 feet? 1, did you say 1.5? Yeah, 1.5. I thought you said 2 for a second. So that means this length would have to be 1.5, right? And this length over here would have to be 1.5 for this point to be in the middle. Make sure you get the homework written down, Victoria, before you leave. Great. Then if you want to grab the notes off your desk there. Okay, so 1.5, 1.5. So it divides the segment into 2 congruent segments. That's a midpoint. Now we're going to add something new into our vocabulary, which is called a segment bisector. And a segment bisector can be a point, which means it would just be a midpoint, a ray, line segment, or a plane, which we don't really see planes too often, bisecting something, that intersects the segment at its midpoint. So a point, ray, line segment, or plane that intersects the segment at its midpoint. So whenever you see the word bisector, okay, usually we think of the word bi as 2, right? Bicycle, 2 wheels. Okay, bisector, it's intersecting it or secting it into 2 spots at the midpoint. So what are some examples of segment bisectors? Well, we've got our basic one. So let's do A, B. If we had a point being our bisector, we'll make it point C. So if something is bisecting it at its midpoint, what did we say midpoint was? It's a point that divides a segment into 2 congruent segments. How do we show congruency on segments? The little symbol, the little tick line, right? Tick marks. So C would be bisecting line segment AB. Or maybe we have a line bisecting it. So again, let's put C in the middle. And let's put a line going through point C. Let's call that line M. That would be a segment bisector. Okay? So pretty much anything that cuts through the middle of a line segment, we see something being bisected at the midpoint. So, I don't know if you want to put a little star off to the margin somewhere. Whenever you see the word bisect, you should be think cuts in half, or 2 equal parts, or, I don't know, the middle. Okay? Because we're going to be using the word bisect quite a lot throughout this course. Okay, so you should come second nature to the word bisect. Okay?
Can you stay on this side?
Yep, I can. Sure. Now, I'll apologize for my diagram in example 1, because that nowhere near looks like T is in the middle. I didn't do a very good job of making my diagram. But we're going to pretend. We can use our imagination, right, Tyler?
Yeah.
I haven't used your imagination in a while. This diagram. T does not look like it's in the middle there, does it? Not really, huh? Okay, so you should still have the formula spot blank because we'll get to that tomorrow. We're not going to worry about the formula today. We'll just do the easy stuff today and make it a little bit harder tomorrow. That's okay with you all. We're good? Yeah. All right, so first example. What do we have happening here? It says line segment VW bisects at point T. Again, that's actually, that should be shifted over a little bit. And it's telling me that, what does it mean, xt with no symbol above it? What does this mean with no symbol above it? The length, right? The distance between x and t. So the distance between x and t is 39.9. So because I see the word bisects at point T, that means that T is what specific point? The midpoint. What does the midpoint mean? That we're split into two congruent segments. So let's mark it. Again, I apologize. That diagram's really bad. It doesn't look like it. So we're going to use our imaginations. Okay. So x to t is 39.9 centimeters. What does it mean to have congruent segments? They're the same. So what would be the length from t to y? The same, 39.9 centimeters. So now what's the problem asking us to find? X to y. So it's 39.9 plus 39.9. Okay, yeah, mental math. I'm going to round this up to 40, right? That's on the calculator. So 40 and 40 makes 80. What should I subtract from 80? 0.2. So take away 0.2 from 80, what do we get? 79.8. Good. All right, so xy is equal to 79.8 centimeters. Okay. So you see the word bisect. That means we've got a midpoint. Because we've got a midpoint, that means we've got two congruent segments. Okay? Questions with that one? Easy enough? Good. I told you we were going to keep it easy today. Next one, point M is the midpoint of line segment VW. What would VM be? Well, the diagram's telling me the whole thing is 46, because this is the midpoint. What's true about these guys? They are the same. So Kaylee, what would it be? Good. So VM is equal to half of 46, which would be 23. All right, we ready to throw some algebra into our lives? Yeah. Now, don't get confused with the algebra problems that we did in section 1.2, where we did segment addition for this next example. Because what's happening now, notice it's telling me that I have a midpoint. So because M is the midpoint, what's true about the left side and the right side? Kaylee? Yeah, so they're equal to each other. Okay, we are not adding them together. And this is where students are going to make mistakes when they have these problems together combined into an assessment. They'll try to add these together, 3x minus 1 plus 20, which we could do, but do I know the whole entire length? No. So I don't have anything to equal it to. So because I see the word midpoint, and because I have these tick marks shown, that means the left equals the right. How do I solve that? Add 1, divide by 3, which gets us 7, Oh, that's nice. Look what the directions are asking us for. Solve for x. So am I done? Yes. Good. All right. So really quickly, those are the only three we're doing. Want to grab yourself a practice space. So if you want to run over and grab a Smart Pal sleeve or just a piece of scratch paper, that's up to you. But find something to do some work on. We're going to try some of these out before I set you off.